The next one, solving inequalities. I do these differently than Alex because they make up all these weird rules and you have to look them up all the time anyway. Following the same idea of what we did here, I'm going to have two cases because I have an absolute value problem. The first one, I'm going to leave this exactly the same as it was, just without the absolute values. So 4x minus 2 is greater than 6. For my second case, when I make this a negative, I also have to flip my inequality sign. So for the second problem, 4x minus 2 is going to be less than my negative 6. And then I'm just going to solve those two things like I solve everything else. So I'm going to add my 2. 4x is greater than 8. Divide by 4. X is greater than 2. On the other one, same thing. I'm going to add my 2 first. 4x is less than negative 4. Divide by 4. X is less than negative 1. Question?
On my paper it doesn't say 4x.
Now what did I have for my two answers? X was greater than 2. X was less than negative 1. So putting those on our graph, if we have the equal to bar underneath, we use the filled in dot. If we don't have the equal to bar underneath, we use the open circle. Put your end marks on first. So I'm going to put an open circle on the 2 and an open circle on the negative 1. I am greater than the 2, so I'm shading to the right side of the 2. I am less than the negative 1, so I'm shading on the left side of the negative 1. So when this is a greater than to start out with, you end up shading the two outsides because I'm greater than so many places from the middle of my crazy expression. And so if that's a greater than, you'll see on Alex, they're going to set up this whole thing and then they're going to say it's an or in between. It's an or in between because you end up shading the two outsides of your graph. So number 11, we're doing our absolute value problem with an inequality. We said that the first case, we're just going to leave it exactly the same. 4x plus 4 is less than or equal to 8. On our second problem, we leave the absolute value part, the 4x plus 4, and then when we do the negative, we have to flip our inequality sign. So we're going to make it greater than or equal to negative 8. We're then just going to solve those two inequalities separately. So on the first one, solving that for x, I'm going to minus my 4. 4x is less than or equal to 8 minus 4 is 4. Dividing by 4, x is going to be less than or equal to 1. On the other part, I'm going to minus my 4. 4x is greater than or equal to negative 12. Dividing by my 4, x is greater than or equal to negative 3. Looking at our end marks, we have the less than or equal to. Since we have the equal to, we use the filled in circle. So we have a filled in circle at 1. We have a filled in circle at negative 3. We are less than the 1, so we're on the left side of the 1, but we're greater than the negative 3, so we're on the right side of the negative 3. Which means our x value is between those two dots. Remember I said earlier, if this is a greater than, you end up shading the two outsides, like on the previous problem. If this is a less than, I'm less than so many places from the middle, I end up shading between my two dots. And that's why the Alex program has two different explanations, depending on if you have a greater than or a less than to start with. But I just do it where you have the original problem, and then you flip your inequality when you do the negative, and you should end up being able to see where you shade by the time you're done. Number 12. If I have the absolute value of negative 2x plus 7 is greater than or equal to 3, what should my two problems be? Negative 2x plus 7 is greater than or equal to 3. The same problem, just without the absolute values. And then my second problem should be
Negative 2x plus 7 is less than or equal to negative 3.
exactly negative 2x plus 7 is less than or equal to the negative 3, flipping my inequality and then changing the sign. And again, on Alex, they're not going to do it this way. They're going to set up this big long table and say if it's a greater than, you got to do it this way. If it's less than, you got to do it this way. Then you got to learn 2 different ways to do the problem. So solving this, we'll see if it comes out any better. I'm going to subtract my 7 first. So negative 2x is greater than or equal to negative 4. When I divide by negative 2, what do I have to do?
No solution?
Nope.
Oh.
When I'm solving an inequality and I divide by a negative, what do I have to do?
That was positive.
It does become positive. What do I do to my inequality sign? I have to switch it around. So x is going to end up being less than or equal to positive 2. When you solve your inequality, if you multiply or divide, which is usually the case, by a negative, you got to flip that sign. Now we're going to have to do that one and this one then too. So minusing my 7, negative 2x will be less than or equal to negative 10. And when I divide by my negative 2, my answer is going to be x is greater than or equal to 5 then, right? What kind of dots should I have on my numbers?
Filled in.
The filled in ones at 2 and at 5. And I'm shading less than the 2. So on the left side, greater than the 5, so on the right side. But you can see this was a greater than to start with, and we know that when we start with the greater than, we should end up shading the 2 outsides of our expression. And we did. So that's a good check. If that's a greater than, you shade on the outsides of the dots. If it's a less than, inside the middle of the dots. Because they're talking about a distance either being greater than so many spaces or less than so many spaces. Mm-hmm.
Is that, what homework day are you on?
13. Only I changed those 3 problems a little bit.
Okay.
Angelique, she informed me that, oh yeah, and then I went